Hi students, in this session we are going to learn SN1 and SN2 type of reaction and its mechanism. Okay. First, I want to write one general equation. Reactants gives products. Okay. Here, reactant consists of two. One is substrate and another one is reagent. Okay, when these two combines together, okay, and it forms the product haloalkanes. Okay, before it forms product, it forms one of the intermediate. Okay, so intermediate can be classified into three. It may be carbocation or carbanion or free radical. Okay, intermediate may be transition state. Now reagent. Okay, come to here. Substrate combined with reagent, it forms product, right? Okay, so here reagent means what? Okay, so listen, reagent means the substance which one go and attack the substrate. Okay, substance which one go and attack the substrate, it is generally called as what? Reagent. Okay, then what about the substrate? Substrate means being attacked by reagent. Okay, that is called as what? Substrate. Okay, I hope you understood what is meant by substrate and reagent. Okay. Now, the reagent can be classified into two. One is electrophile and another one is nucleophile. So, what does mean by electrophile? We already learnt, right? Listen, electrophile means electron deficient species that are called as what? Electrophile. Okay. Now come to nucleophile. Nucleophile means what? Just opposite of it. Electron rich species are called as what? Nucleophile. Okay. It can be called as electron pair donor species also. Okay. Then nucleophile may be positive charged species or neutral. Okay. Now we are going to see the example for nucleophile. The best example for nucleophile is what? OH minus, Cn minus. These are negative species, right? For a neutral molecule nucleophile, we just take H2O. Okay. Now come to here. Now we need to know the type of solvent, right? Okay, because the solvents are placed in important role here, right? Okay, so first types of solvent we are going to see. Listen, so based on its nature, polarized nature, we can classify that into two. One is polar and another one is non-polar solvent. Okay, polar solvent and non-polar solvent. For non-polar solvent, we just write the example hexane and hexane, otherwise cyclohexane or benzene. These are some of the examples for non-polar solvents. Okay. Now come to the important topic, polar solvent. Okay. Polar solvent can be further classified into two. Okay. So the first one is polar protic solvent and another one is polar aprotic solvent. Okay. Polar protic solvent and polar aprotic solvent. Okay. So polar protic solvent short form PP and for polar aprotic the short form is PA. Okay. Now listen, polar protic solvent means what? Which one easily gives H plus ions that are called as what? Polar protic. So what is mean by polar aprotic? Polar aprotic means it won't gives H plus ions, that are polar aprotic solvent. For polar protic solvent, we just write the examples. Listen here, water, alcohol, acetic acid. Okay, These are some of the examples for polar protic solvent. These three easily gives its hydrogen. What about polar aprotic solvent? Polar aprotic solvent means which one won't gives H plus ions, right? Here the best example is given, that is what? Acetone. Okay, acetone is the best example for polar aprotic solvent. Okay, next one, instead of carbon I just write sulfur. Okay, that are dimethyl sulfoxide. Okay. These are some of the example for polar aprotic solvent. Okay. Listen, now we are going to see SN1 type of reaction briefly. Okay, SN1. What is mean by it? Okay, listen, we have to write SN1 like this. Okay, N means what? Nucleophilic substitution. SN means nucleophilic substitution reaction. Okay, so it follows first order kinetics. That's why we mentioned they are 1. Okay, so here N indicates the reagent, nucleophilic reagent, and S indicates what? Substitution. Okay, so that's why this reaction called as what? Nucleophilic substitution reaction. Okay, now come to the general equation. Okay, nucleophile means what? Electron rich species, right? Okay, listen, here we are going to take one example for substrate. Okay, substrate example, we just take one example, CX or a halo alkane group. Okay, listen, here halogens are more electronegative than carbon. That's why it undergo polarization partially, and carbon has partially positive charge, and halogen has partially negative charge. Okay, so what happened here? Now that electrophile or nucleophile may attract the substrate actually, right? But carbon has positive charge, right? That's why nucleophile going to be attack the compound. Is it clear? Okay, that's why this type of reaction called as what? Nucleophilic substitution reaction. Okay, I already told you that 1 indicates what? It follows first order kinetics. Okay, and nucleophilic substitution which follows first order, okay, that are generally called as unimolecular nucleophilic substitution reaction. Okay, listen. Now we take one example for SN1. Okay, and going to explain its mechanism. Listen, here we take one compound. Okay, carbon just surround us different 4 groups. Okay, here one group must be halo group, right? Because haloalkenes, right? Okay, so listen, this compound when attacked by nucleophile, it forms the product. But here that nucleophile not easily attack the carbon. Reason, 4 different groups, right? 3 different groups are just surrounded there, right? That 3 groups may be bulky groups. Okay, so when the carbon containing 3 bulky groups along with the halogen, that group not easily attacked by nucleophile. So the first step is what? The first step, halogen going to be removed from the compound. Okay, so it forms what? Carbocation. Is it clear? Already I told you halogens are more electronegative than carbon, right? So it takes 2 electron and it going as a X minus ion. So carbon compound just form as a carbocation. Is it clear? Now we are going to check the hybridization of it. When we take the reactant side, the carbon hybridization is sp3. So after we removing halo groups, what happened? It forms carbocation, right? So the hybridization changed to sp2. Okay, so the geometry trigonal planar. Okay, so due to its geometry, nucleophile can attack this side or that side. Okay, then So what happened? We can write two different compounds there, right? First, right side we substituted nucleophile. The next compound we substituted the nucleophile on the left side of it, right? It can able to form two different compounds like this. When we passed plain polarized light through this solution, okay, one molecule may rotate the light towards left hand direction and another one molecule may rotate the light towards the right hand direction. So both rotation get cancelled together and there is no net resultant direction. Okay, so such type of mixture is called as what? Racemic mixture. Okay, so SN1 always gives racemic mixture, my dears. So once again we revise the same. When we take one haloalkane group, first the hybridization of the carbon is sp3. After the first step, it change into sp2. When it forms intermediate, it change into sp2. Then finally it forms the product. Okay, I already told you SN1 reactions are always follows first order kinetics. Okay guys, listen my dears, in this reaction the first step is the slowest step, okay, and the next one is a fast one. Okay, so this slowest step only helps to determine the rate of the reaction. Okay, that's why the first step in SN1 reaction is generally called as what? Rate determining step, RDS. That means rate only determines based on the slowest step. Rate is directly proportional to the concentration of the reactant. Is it clear? Okay.